Find the particular solution to the equation 2x prime plus x equals 3t squared. So as always, we need to make our homogeneous solution so that we can find the roots using the auxiliary equation. Thus, our left-hand side stays the same, but we change our right-hand side to equal 0. And for our roots, r equals the amount of derivatives being taken on x for this case. So it would be 2r plus 1, since the coefficient of x is 1, and there's no prime being taken there. So it's just 2r plus 1 equals 0. This is a pretty straightforward case, so we set 2r equal to -1, and dividing by 2, we have our one solution, r homogeneous, equal to -1/2. It's pretty fast. Now, moving on to our particular solution, really quick, I just want to let x equal y, because I'm used to using y notation, but you can replace either one. So in this case, the particular solution will have the general format ay prime plus b equal to some constant capital C times t to the m e to the rt, where r in this case is particular solution. It's not the same thing as r homogeneous. And we can quickly tell that there is no e term, however there is a t term on the right hand side with a constant, and since there's no sine or cosine, we don't have to worry about any alpha or beta, so we can quickly tell that m equals 2, since it's t to the power of 2, and rp equals 0, since e to the 0 is 1, which effectively cancels itself out. This implies that it's also not equal to rh, which as we said was -1/2. Therefore, s is 0, which is needed when we set our general format y particular equal to t to the s times a decreasing polynomial of degree m, a sub m, times t to the m, plus a sub m minus 1, t to the m minus 1, so on and so forth, until we hit a sub 1t plus a sub 0 times e to the rpt. Plugging in what we already found, this should be equal to t to the 0, since s equals 0. And now m equals 2, so we have to elaborate up to the second degree. So it'd be a sub 2, t to the second, plus a sub 1, t, technically to the first, plus a sub 0, times e to the 0, which again equals simply at squared plus bt plus c. It's easier to use different letters, and that's it. So now what we have to do is take simply one derivative of y, or x technically, to plug everything back into this equation, and we can find the undetermined coefficient. So let's rewrite that here. Yp equals at squared plus bt plus c. Yp prime equals 2at, moving the exponential term to the front, plus b, since there's only one independent variable, and c cancels itself out. And this is all we need. We don't even need to take a second derivative. So plugging that in to, I'll say 2y prime plus y equals 3t squared. 2 times yp prime, 2at plus b, plus just y, at squared plus bt plus c. And this equals our normal right-hand side, 3t squared. Now let's try to solve this. So distributing the 2, we get 4 at plus 2b plus at squared plus bt plus c equals 3t squared. Now, do we have any like terms? Obviously not, so let's try to reorder the powers now, starting with t to the highest power. So we start off with at squared plus 4at plus bt plus 2b plus c. So we kind of leave the constants out here, equals 3t squared. Now our goal is to match every term with t along with the a and b term as well as c. By that I mean we have to decrease this polynomial on the right hand side. So it's 3t squared plus 0t plus 0. This is the same thing. So now you can see what I'm trying to get at here. We can match 2b plus c with the 0t term, and we can match the 4at plus bt with this term, 0t, which leaves us with our last term, at squared, with 3t squared. Now, of course, this gives us a system of equations. Let's go through it. So starting with t to the second, we have a, we can leave out the t squared now, equals 3. We already have our first solution. Now for t to the 1th power, we have 4at, so 4a plus b equals 0. We're trying to find b since we already have a. So b equals 0 minus 4a, which equals negative 4 times 3, which is negative 12. Therefore, b equals negative 12. Our second solution. Now we have t to the 0, or just our constants, where we have 2b plus c, equal to 0 once more. Following the same pattern, we're trying to find c, so c equals negative 2b, which equals negative 2 times negative 12, which equals positive 24. Thus, c equals positive 24, which gives us our final answer for y particular. And now all we have to do is plug in a, b, and c back into this equation right here. So at squared becomes 3t squared, since a equals 3, plus bt, b is minus 12, so minus 12 times t, plus c, plus 24. And that's our answer. We don't have to include our homogeneous solution since it never asked for it, but it is necessary to evaluate since the roots can sometimes repeat themselves, which would just bring everything up by power t. So I hope this helped. If it did, please like and subscribe, and I'll see you in the next video.